Hello and welcome to another video presentation courtesy of the University of North Texas Physics Department with the assistant of the Physics Demo Room. My name is Corey Nook and I'm going to be looking at a demonstration today with you that has to deal with balanced forces using a little mini fan and a couple of balloons. So what we're trying to look at today is how do I make a balloon just balance in the air with just using a fan? And why does that work? So in order for that to work, we have to have enough push or enough force exerted from the fan in the terms of air, because of all the air molecules, hits up against the balloon to create a balanced force or a net force being zero. This is kind of similar to the concept of a hovercraft. You have air pushing down the exact same amount of force as pushing down, which pushes the aircraft up and counteracts the force of gravity acting on the hovercraft. So if we look at our free body diagram, FBD stands for free body diagram that I've drawn on the board. Remember, with every good free body diagram, you want to have your axes labeled. So you want a vertical axis and a horizontal axis labeled what direction is positive. So in the case of our object being the balloon, we obviously have the force due to gravity in the negative y direction of magnitude of the mass of the balloon times gravity. And we have that the force from the fan on the balloon is in the upwards direction. So when we look at Newton's second law that the sum of all forces has to equal mass times acceleration, or the net acceleration, if this balloon doesn't move up or down and hovers, that means that the net force acting on it is equal to zero, which means that the magnitude of our force of air equals the magnitude of the force of gravity, but just in opposite directions. So now, what I'm going to try to do is take this little fan, this little balloon, and make it hover above it. So, I have the fan spinning, not spinning. That way you can see it spinning, you can hear the hum. So now what I'm going to do is I'm going to place the balloon here. And as you can see, it's in perfect equilibrium, that way it's not touching, or if it does, it touches maybe just a little bit, but it's just now hovering right above it. And so I can say, well, let me try it with a different balloon. What really helps with this concept of why this is able to work is because the actual latex of the balloon almost doesn't add that much mass to it. So it's really air against air. And that's why we're able to keep it just perfectly in one spot. It'd be a lot different if, let's say, we had feathers, or if we had sawdust, or a different object. It's really a lot easier to do if you have something that's similar to air. But you can't just have any object. You've got to be careful with how much air you use. So like, say, for example, this beach ball, a lot of air. This fan only produces so much air. Doesn't work. So this is where you have to kind of know the amount of air that you're pushing and the air that you're going to be looking against. Same kind of concept which goes to hovercrafts as well. Well, thank you for your attention for this video presentation and have a wonderful day.